Hi, I'm really excited about this deck of cards. Everything was extracted from the MCAT style passage, Miller's Law, chunking, and the capacity for working memory. And the reason why I'm so excited is because they contain psychological and biological foundations of behavior content, specifically in the area of statistics and significance testing. And if you're not that familiar with that kind of stuff, it's fine because I'm going to release more cards specifically on statistics. Okay? All right. The phonological store capacity is around blank seconds. So how long is the phonological store capacity? And for those of you who don't know, the phonological store comes out of the working memory model, and it represents the ability to briefly store auditory information, like words that you hear someone say. Okay? And the answer is 2. So our phonological store is around 2 seconds. And as I was previously just hinting at, the phonological loop is a concept of working memory. And it's basically our ability to store verbal information. So the verbal information you hear, and then your articulatory control system, or your mouth basically, and your voice box, sound producing organs can rehearse it, and then you can keep on going in this loop, and it leads to you remembering it and either storing it in short-term or long-term memory. So when someone speaks, your like ability to remember is 2 seconds long, according to this model at least. All right, now for statistics. A type blank error or a false positive, okay, is the incorrect rejection of the null hypothesis. So what's the answer? And if you don't know what the null hypothesis is, I'll get into it a little bit and then in more detail in statistics flashcards. That would be a type 1 error. So here goes a chart for hypothesis testing outcomes, okay? And so if in reality the null hypothesis is true, but in your research you say the alternative hypothesis is true, that means you reject the null hypothesis, then you've committed a type 1 error, and which yields a sad face. And so this is like a normal distribution curve, and in here is the probability that you get the accurate choice. You correctly say that the mean is equal to some value k that you found in your research. But out here on the outskirts, if this is a two-tailed test, by the way, this is where you commit a type 1 error. And for a two-tailed test, if the probability of you committing a type 1 error is alpha, you're going to split that in half to make a nice even two-tail alpha region, okay? And it's okay if you don't completely get this. I'll get into it later. A type blank error or a false negative is the incorrect acceptance of the null hypothesis that is actually false. So what type of error is this? I'll give you a moment to think. That would be a type 2 error, as I'm sure you probably guessed. So if in reality the alternative hypothesis is true, but in your research experiment you said the null hypothesis is true, then you've committed a type 2 error, okay? So this represents the null hypothesis, okay? But this is where you said your HA or alternative hypothesis is true, and this is like the true population mean that you got. But in reality, that's not the mean. Mu, remember, represents population mean. That's just like the average. You got something else that's like a wrong average. So the likelihood of you committing a type 2 error is beta, and it's like a one-sided left tail probability for a wrong normal distribution. Okay? So just take that in for a moment. Actually, just pause the video. I don't want to make this too long. All right, on to the next card. A p-value that is greater or less than the significance criterion denotes that the results were significant. So what's the answer? Does the p-value have to be greater or less than the threshold, the cutoff point? All right, so basically the answer is less, okay? And so let's say the p-value is 5, all right? And that would mean that 95% of all results would fall in the green area if HO, the null hypothesis, is true. And then, for a normal standard distribution, or for a normal distribution, the true mean would be 0 if the null hypothesis is true. But let's say the null hypothesis is not true. The likelihood of it happening by chance is like in this region right here. And so I'll give you a moment to take this in. And if you got that part, let's just like review p-values. So basically, the smaller the p-value, the stronger a conclusion you can make. So if a p-value is greater than 0.1 or 10%, there's no evidence against the null hypothesis. If a p-value is between 5 and 10%, then there's weak evidence against the null hypothesis. If the p-value is between 1% and 5%, there's moderate evidence against the null hypothesis. If the p-value is between, let's say, how much is that? So if the p-value is less than 5%, but greater than 0.1%, then there's good evidence against the null hypothesis. If the p-value is between, let's say 1% and 0.1%, there's strong evidence against the null hypothesis. I think this is supposed to be 0.1, yeah, between 1% and 5%. And then if the p-value is less than 0.1%, then there's very strong evidence against the null hypothesis. So that means that, the likelihood of things happening by chance are really low in this region. But this still might be confusing to you, and that's okay. I'll cover it when I do statistics flashcards. Okay? 2 successive binary decisions would equal blank binary alternatives. So what's the answer? And if you don't know what binary decisions are, don't worry, you'll learn on the flip side of this flashcard. All right, so that would mean 4 binary decisions. And the simplest successive binary decision I could have thought of was flipping a coin once, recording it, and then flipping it a second time, a fair coin toss 2 times, okay, one after the other. So the first time you throw up the coin, you can get a heads or a tails, and then the second time, you can get a heads or a tails after your first heads, or a head or a tail after your first tail, leaving you with outcome 2, outcome 3, outcome 4. So these are the 4 possible binary outcomes, okay? The blank memory system utilizes numbers, rhymes, shapes, and sounds to create a scene based on a mental hook. So what memory system is this? And some of you might have already encountered this even if you don't know the name. All right, that's the PEG memory system. And this is what a PEG is, like the little spooks on a coat rack, on, a mounted coat rack. And so this is like a really good PEG system. I like this one. I don't know a lot of them, but I know I can guess a few. So I encourage you to pause and see how much you can guess. Usually a car has 4 doors. You have 5 fingers. Oh yeah, and this PEG system is for like counting, teaching little kids numbers. You have 2 eyeballs. There's 3 sides on a triangle. 7 up is obvious. An octopus has 8 legs. Baseball has 9 innings. Don't know what the rooster and the 10 stand for. Don't know much about football, so can't say about that. There's 12 dozen eggs in a carton. Like Friday the 13th and black cats, bad luck, old superstition or whatever. And then the 14th of the heart represents Valentine's Day, February the 14th. I'm sure this has to do something with tennis scoring, but I don't know what the 15. Oh yeah, I think there's 15. Okay, whatever. I don't know. Okay, quickly. You get your driver's license at 16, 17 magazine. You graduate from high school at 18. Might this be a 19-inch computer monitor, $20 bill? You can go to Vegas and gamble at 21. I like this one, a tutu, or the number 22. Almost everyone knows Jordan has like the number 23. 24 hours in a day, you're running out of time, a quarter, and then there's 26 letters in the alphabet. I don't know about this Rubik's Cube. I'm not really sure about it. Yeah, so that's it. Okay, let's continue. The blank memory system utilizes order, okay, and connections or links to facilitate memory recovery. So what memory system is this? All right. That's going to be the links memory system. Here depicted is a link. Memory builds upon small units of information or linkages. And so that's that. Okay. Bye.